Puzzles, magic circles. Now let's see for this magic circle problem. Check the sum of the opposite pairs, which is 4 plus 2 is equal to 6 and 6 plus 3 is equal to 9. The central number is 2. Doesn't look like there's a relation this way. Can we check the product of the opposite pairs? 4 into 2 is equal to 8. 6 into 3 is 18. The central number is 2. Doesn't look there's a relation this way. So let's try the sum of adjacent numbers. What is adjacent numbers? Numbers next to each other. So 4 plus 6 is 10. 3 plus 2 is 5. The central number is 2. So 10 divided by 5 is 2. So let's see if this works for circle number 2. Check sum of adjacent numbers. 12 plus 9 is 21. 3 plus 4 is 7. So the central number is what? 3. How do you get that? 21 divided by 7 is 3. So this rule is correct. Hooray! Let's try this for the third magic circle. The adjacent numbers are 11 plus 19, which is 30, and 6 plus 4, which is 10. 30 divided by 10 is 3. The option is option number 3, which is 3. Now try this one. Check the sum of the opposite pairs. 15 plus 2 is 17. 10 plus 12 is 22. The center number is 150. What could the rule be? Doesn't seem to be a relation. Let's try something else. Check the product of the opposite pairs. 15 into 2 is 30. 10 into 12 is 120. So the center number is 150. What could a relationship be? Could it be 30 plus 120 is equal to 150? Let's check for the second circle. Check product of the opposite pairs. 10 into 5 plus 8 into 7 is equal to 106. So the rule is correct. Let's try this for the third one and get the answer. Check the product of the opposite pairs. 10 into 10 is equal to 100. 8 into 8 is equal to 64. The answer is 164, option number 3. Come on, you can do this one. It's easy, right? The inside number is the sum of the product of pairs. The answer is 10 into 4 plus 8 into 7 is equal to 40 plus 56, which is equal to 96. So 96 is the correct answer. Now this one. You can do this one too. The inside number is equal to sum of product of the pairs. The answer is 10 into 12 plus 8 into 9, which is 120 plus 72, which is 192. Option number 4. Now, what about this one? Does it look challenging? Let's see. Check the sum of the adjacent pairs. 11 plus 15 is 26. 11 plus 15 is 26. Center number is 0. I wonder what we can do. The rule could be 26 minus 26 is equal to 0. Let's try it for circle number 2. Check the sum of the adjacent pairs, which is 10 plus 8, 18, and 10 plus 7, 17. Center number is 10. So check the rule. 18 minus 17 is 1. So this rule doesn't work. We have to go back to the first circle. Check the product of the adjacent pairs. 11 into 15 is 165. 11 into 15 is 165. Center number is 0. So 165 minus 165 is 0. Let's try this for the second circle. 10 into 8 is 80. And 10 into 7 is 70. And the center number is 10. 80 minus 70 gives 10. That's right. So this rule works. Let's apply this to the third magic circle. Check the product of the adjacent pairs. 10 into 8 is equal to 80. 9 into 6 is 54. 80 minus 54 is 26. So the option number 2, 26, is correct. You can do this one. Come on. The inside is equal to difference of product of the adjacent numbers. What's the answer then? 10 into 9 minus 9 into 6. So 90 minus 54, 36. What about this one? Check the sum of the opposites. 1 plus 5 is 6. 3 plus 2 is 5. Center number is 39. So what could the rule be? Can't really find a link here. Let's try something else. Check the sum of the adjacent numbers. 1 plus 3 is equal to 4. 2 plus 5 is equal to 7. The rule... can't find the rule here too. Check the product of the opposites. 1 into 5 is 5. 3 into 2 is 6. So what's the rule? Can't find a relation here too. Check the product of the adjacent numbers. 1 into 3 is 3. 5 into 2 is 10. Rule... This seems to be a little difficult, huh? Let's try something else. Check the sum of the squares. 3 square plus 1 square plus 2 square plus 5 square is 9 plus 1 plus 4 plus 25. What is the answer? That's the link, 39. So let's check for the second circle. We add the sum of the squares of the numbers in the outside part of the circle. So 4 square plus 5 square plus 3 square plus 1 square will be 16 plus 25 plus 9 plus 1. Don't forget that 1. So the answer is 51. So this rule works. Let's get this for the third magic circle. So 2 square plus 3 square plus 2 square plus 2 square would be 4 plus 9 plus 4 plus 4, which is 21. So the correct answer is option 2, 21. Come on, you can do this one. It's easy. The inside number is equal to sum of the squares of the outside number. The answer is 329. Come on, you can do this one. What's your rule? The inside number is sum of the squares of the outside. What's the answer? 10 square plus 10 square plus 20 square plus 30 square is 100 plus 100 plus 400 plus 900. The answer is 1500. What's this? How do you solve this one? Check the sum of the adjacent pairs, which is 5 plus 7, which is 12. 3 plus 3 is 9. The center number is 35. Doesn't seem to be a relation. Center number is 35. So let's check the sum of the opposite pairs. 5 plus 3 is equal to 8. 7 plus 3 is equal to 10. So what's the rule? Doesn't seem to be a relation. Let's try something else. Check the sum of the squares. 7 square plus 5 square plus 3 square plus 3 square is 49 plus 25 plus 9 plus 9, which is 92. Doesn't seem to be relation with the inside number. Let's try another trick. Product of top divided by bottom. So 7 into 5 into 3 divided by 3, which is 105 divided by 3, which is 35. This sounds exciting. Is this a rule? This could be it. Let's check for the second diagram. The product of the top divided by the bottom number is 2 into 5 into 6, which is 60, divided by 2, which is 30. Hooray! We got this number. We got the formula. So apply it to diagram number 3. The product of top divided by the bottom number. So 7 into 8 into 9 divided by 8, which is 504 divided by 8, which is 63. So the correct answer is option 2, 63. Now you can do this. It's very easy, right? What's the rule? The inside number is the product of the top numbers divided by the number at the bottom. What's the answer then? 2 into 3 into 2 divided by 2. So the answer is 6. Come on, you can do this too. The rule remains the same. The inside number is equal to the product of top numbers divided by the number at the bottom. What's the answer then? 5 into 3 into 2 divided by 2, which is 30 divided by 2, which is 15. Now let's check for this problem. What is the first check that we do? Check the sum of the opposite pairs. Let's say 5 plus 3 is equal to 8. 7 plus 3 is 10. The center number is 5. Is there a relation between these numbers? No, it doesn't seem like a relationship. Now let's try sum of the adjacent pairs. So 7 plus 5 is 12 and 3 plus 3 is 6. Is there a rule? Doesn't seem like a rule. Now let's check the product of the adjacent pairs. So 7 into 5 is 35 and 3 into 3 is 9. Is there a rule somewhere here? No, doesn't seem to be a relation. Now let's check opposite pairs product. So 5 into 3 is 15 and 7 into 3 is 21. Is there a relation? No, doesn't seem like. One more try. Check the sum of the squares. 7 square plus 5 square plus 3 square plus 3 square is 49 plus 25 plus 9 plus 9, which is 92. But the center number is 5. So doesn't seem like a relation again. One more try. Let's try adding the top numbers and dividing by the number at the bottom. 7 plus 5 plus 3 divided by 3 is equal to 15 divided by 3, which is 5. The center number is 5. So is that a rule? This could be it. Let's check for the second magic circle. For the second circle, you add 2 plus 5 plus 7 divided by 2, which is 14 divided by 2, which is equal to 7. And the center number is 7. So yes, this rule works. Let's solve this problem now. We add 7 plus 8 plus 9 and we divide with 8. So we get 24 divided by 8, which is equal to 3. So the center number is 3 and the answer is option 2, 3. And that brings us to the end of this lesson. So you have to remember to be patient and to keep trying various combinations to solve the magic circle problems.